Okay, this is going to be our first flipped instruction, and what this does is it gets you ready with the background information, so when you come into class, we're ready to rock and roll and go with our lab over Newton's second law, which is about the law of force and acceleration. Newton came up with these three laws because he noticed that whenever you have motion, you have these common things that happen all the time anytime there's movement. So you need to get your journal out. You need to add to your table of contents this second law, law of force and acceleration. Find the page number, and then you're going to flip back over to that page and you're going to set it up in Cornell Notes style. Make sure you title it Newton's Law of Force and Acceleration on that page and put your line on the left. Now remember, you can pause and rewind this video or the recording as needed for you to stop and write. Okay, moving along, you're going to need to put Newton's second law, law of force and acceleration, on the left, and these are the 4 bullets you're going to put on the right. Number 1, the law we have here is that the greater the force, the greater the acceleration of an object. So think about this. If you go to the grocery store with your parents and you're pushing the shopping cart, the more force you push on that cart, the faster your cart is going to begin to move. And so I'm going to use this shopping cart example a lot as we talk about these laws of motion. The second aspect in his law of force and acceleration is that if you have a greater mass, then you're going to need a greater force to make that mass accelerate the same as a lighter mass. So let's pretend you have a brother or sister and you have 2 carts and you've put all the groceries in one cart and the other cart's empty. Well, you and your brother and sister are probably going to get in trouble, but you're going to want to race down the aisle. Well, who's going to need the greater force to make your carts go the same speed? Obviously, if you have more groceries and you have more mass in one cart, you're going to need to push with more force to keep up with your brother or sister. So Newton figured out that there is this relationship, and we can use this formula that's calculated by taking and stating that the force needed is equal to the mass of the object times the acceleration of the object. And so we're going to be using that little handy-dandy triangle to figure this out. Here's another example with some cars here. You have a little car that's 1,000 kilograms and you have a big van that's 2,000 kilograms. If you want both of these cars to go 0.05 meters per second squared, which car are you going to need to use more force with? Obviously, it's going to be this one. Okay, moving along now, let's look at some examples. So go ahead and put examples on the left side of your paper. And on the right, I would like you to write down at least at least 2 of these examples. So, first of all, if you hit a baseball, the harder you hit the ball, the faster the ball is going to go. So there's your force part. Accelerating or decelerating a car, if you slam on the brakes hard, you're going to stop faster. If you push on the accelerator really with a lot of force or all the way down, you're going to accelerate faster. Think about also, if you watch football, the positioning of football players. They put the bigger players, the more massive players on the line because they're harder to get through. And then they put the lighter, faster to accelerate players in the backfield. If you're really big and really fast, boy, that makes you a really good football player. And then you need to think about a loaded versus an unloaded truck. Think about those big 18-wheelers that are on the road. If you're coming up to a stoplight and you see a little VW Bug on one side and an 18-wheeler on the other, and the light's red, who are you going to want to get behind when the light turns green? Well, obviously, the little VW Bug is going to be able to go faster because it has less mass. So it's going to be able to accelerate faster. It's going to take that loaded truck a long time. Okay, thanks for tuning in to this flipped instruction, and we'll see you in class when we get ready to do our lab on force, mass, and acceleration.